Hello everyone. In this video we are going to see about the permeability of soil. The permeability is very important engineering property of the soil because it has a dominating influence on the total engineering behavior of soil. The permeability is defined as the ability of any porous medium such as soil to transmit fluids through the interconnected voids is known as permeability. Concept of heads. There are three important concept of heads are there, namely pressure head, elevation head, total head. Pressure head HP is the pressure at any point by the unit weight of water. In other words, it is the height to which water rises in the standpipe from the point of insertion. Next, elevation head HE. It is the height of the point from the selected datum level. Next, total head H. It is the sum of pressure head and elevation head. Next, we are going to see Darcy's law. Darcy's law states that the flow velocity is proportional to hydraulic gradient, that is, V is proportional to I. It is also called as discharge velocity or Darcian velocity or superficial velocity. According to Darcy's law, the rate of flow through a soil can be calculated using the equation Q equal to KIA, where K is the coefficient of permeability. The coefficient of permeability is expressed in terms of millimeter per second or centimeter per second or meter per second. Phi is the hydraulic gradient, that is equal to H by L. It is a dimensionless parameter, where A is the total cross-sectional area. Again, the flow velocity can be obtained using the equation V equal to Ki, where the coefficient of permeability K is equal to V divided by I. Next, we are going to see the seepage velocity. The flow velocity is different from the velocity inside the soil porous, which is known as the seepage velocity. The formula for seepage velocity Vs equal to Kp into I, where Kp is the constant of proportionality and it is called coefficient of percolation. The formula for coefficient of percolation Kp equal to K divided by N. The coefficient of percolation is also defined as the ratio of coefficient of permeability to porosity. Next, we are going to see the factors of influencing coefficient of permeability. First one, the size and shape of the soil particles, that is soil type. There are different type of soils having different type of coefficient of permeabilities. Let me see. Gravel, it has a coefficient of permeability of 10 to the power 0 centimeter per second. Coarse sand, it has the coefficient of permeability of 10 to the power 0 to 10 to the power minus 1 centimeter per second. Medium sand, the coefficient of permeability is 10 to the power minus 1 to 10 to the power minus 2 centimeter per second. Fine sand, the coefficient of permeability range in between 10 to the power minus 2 to 10 to the power minus 3 centimeter per second. Very fine sands and silts, it has the coefficient of permeability 10 to the power minus 3 to 10 to the power minus 7. For silts especially, it has the coefficient of permeability of 10 to the power minus 5 centimeter per second. Clay means it has a coefficient of permeability of 10 to the power minus 7 to 10 to the power minus 9 centimeter per second. And also Eisen gives the following equation for clean sands in loose state. The permeability K in centimeter per second is equal to C into D10 the whole square, where C is the empirical coefficient which varies from 90 to 120. Often it is assumed as 100, where D10 is the effective diameter in mm. Second one, the function of void ratio or density. The variation of K with the void ratio can mathematically expressed as K is proportional to E cubed divided by 1 plus E, or K is proportional to E square, or log K is equal to E, where the void ratio will be increased means the coefficient of permeability also increased. So the void ratio is directly proportional to the coefficient of permeability. Next we will see the detailed arrangement of the individual soil grains, that is the structure or the soil fabric. The soil will be in dry state means it has the greater of the coefficient of permeability K when compared to the soil in moisture state. Fourth one, the function of the permeant. It is the ease with which a liquid can flow through a soil also depends on the liquid itself. For example, a thick viscous oil will move at a slower rate than water. Therefore, greater the viscosity, the lower is the permeability. So, the viscosity is indirectly proportional to the coefficient of permeability. The standardized value of K at 20 degrees Celsius. K20 is equal to mu T divided by mu 20 into gamma 20 divided by gamma T into Kt, where K20 equal to value of coefficient of permeability at 20 degrees Celsius, Kt is equal to value of coefficient of permeability at T degrees Celsius, mu 20 is equal to viscosity of permeant at 20 degrees Celsius, mu T is equal to viscosity of permeant at T degrees Celsius, gamma 20 is equal to unit weight of permeant at 20 degrees Celsius, gamma T is equal to unit weight of permeant at T degree Celsius. Fifth one, presence of discontinuities. The presence of air in soil makes it unsaturated and it leads to lesser the coefficient of permeability, where the coefficient of permeability of unsaturated soil will be less than the coefficient of permeability of saturated soil. Generally, K unsaturated divided by K saturated at same void ratio is equal to S divided by 100, the whole power 3.5, where S is the degree of saturation and it is varies from 0 to 100%. If the presence of air means it leads to reduces the coefficient of permeability. Next we are going to see the permeability of stratified soils. First one, flow along the direction of stratification, that is flow at horizontal. The formula for coefficient of permeability at horizontal flow, Kh is equal to K1H1 plus K2H2 plus etc. KnHn divided by H1 plus H2 etc. plus Hn, where Kh is the equivalent coefficient of permeability along the direction of stratification for an equivalent layer of the thickness equal to the sum of the thickness of the all layers, where Kn is the K of the nth layer, Hn is the thickness of the nth layer, N is the total number of soil layers. Next we will see flow perpendicular to the direction of stratification, that is flow at vertical. Kv is equal to H1 plus H2 plus etc. Hn divided by H1 divided by K1 plus H2 divided by K2 plus etc. Hn divided by Kn, where Kv is the average coefficient of permeability at vertical direction. In general, the coefficient of permeability at horizontal flow is always greater than the coefficient of permeability at vertical flow. So the Kh is always greater than Kv. Next we are going to see determination of coefficient of permeability in laboratory test. In laboratory test means there are two methods are there, namely direct method and indirect method. In direct method we have two methods, constant head permeability test and falling head permeability test. In indirect method means we have three tests, namely consolidation test, computation from the grain size and horizontal capillarity test. So first we are going to see constant head permeability test. This test is more suitable for coarse grained soil only. The formula for constant head permeability test, K is equal to QL divided by THA, where Q is the quality of water, L is the length, A is the cross section of the sample, T is the given period of time, and H is the total head. The formula for coefficient of permeability in constant head permeability test K is equal to QL divided by THA, where Q is the quantity of water, L is the length, T is the given period of time, H is the total head, and A is the cross section of sample. Next we are going to see the falling head permeability test. This test is mainly used for fine-grained soils which are relatively less permeable. The formula for finding the coefficient of permeability in falling head permeability test K is equal to A small a L divided by capital A into T2 minus T1 into log E base H1 divided by H2, where T is the period of time and A is the bureaued cross-sectional area. That is, small a means bureaued cross-sectional area, where capital A means cross-sectional area of the sample, and H1, H2 are the heads at times T1 and T2 respectively. Next we are going to see the field methods of determination of coefficient of permeability. There are two type of tests are there: pumping out test and pumping in test. In pumping out test, we have two methods, namely pumping out test in a confined aquifer and pumping out test in an unconfined aquifer. Pumping in test means we have two methods, namely open end test and packer test. First we are going to see pumping out test. In pumping out test, we have two methods, namely unconfined aquifer and confined aquifer. In unconfined aquifer, the formula for finding the coefficient of permeability K is equal to small q divided by 1.36 into Z2 the whole square minus Z1 square into log R2 divided by R1, where Q is the rate of pumping, Z1 and Z2 are the depths of water in observation of well distance, and R1 and R2 from the pumped well from the bottom impervious layer. Second one, confined aquifer. In confined aquifer, the formula for coefficient of permeability K is equal to Q divided by 2.72 H into Z2 minus Z1 into log R2 divided by R1, where Q is the rate of pumping and H is the thickness of the aquifer. Z1 and Z2 are the depths of water in the observation of the well. Thank you for watching this video. Please subscribe our channel for more videos. Thank you.